So hello everybody, my name is Stephen Feuerstein. I'm the developer advocate for PL/SQL here at Oracle Corporation. I've been working with Oracle and PL/SQL technology since 1987 or so. Left Oracle in 92, came back in 2014, and now I'm having a lot of fun helping people use PL/SQL, understand it better, leverage it fully in their applications. Ask Tom Office Hours is a program we set up to start up monthly, regular Q&A, sharing tips and knowledge and expertise about Oracle technologies from our internal experts out to the users, and also getting your feedback back in. So what I'm going to do today is focus on a particular topic, which is fetching a single row inside a PL/SQL program. Now, the name of my office hours is PL/SQL 101, and my idea is to focus on fundamentals. And I've been thinking about this topic and my series in general in the sense that I've realized there's a sense of fractal quality to writing code. You need the big picture. You need an overall architecture of how you're building your code, both the PL/SQL code and the rest of your code. But you also need quality right down at the micro level of every line of code you write. And you can't get one without the other. If you write a lot of really bad code that's hard to maintain, you can't have overall quality of an application. If you have a wonderful architecture, but on a line-by-line basis, your code is nasty, you're not left with much. So fetching a single row is interesting because it's something that we do a lot in the PL/SQL world. The PL/SQL language is so tightly tied to the data. It's really a data API language and business logic language. So we're writing a lot of SQL, and a lot of those are select statements that retrieve a single row. And it turns out, as with any other part of programming, there are lots of ways to do it. So we're going to spend some time looking at that. I'll do a short presentation on various aspects of fetching single rows or different ways to do it. And hopefully we'll have an interesting conversation because many people have very strong opinions about the tiniest little aspects of writing their code. Okay, so first of all, let's do a little bit of housekeeping or administrivia around office hours. So you came in through this page, and this single page, this landing page for PL/SQL 101 office hours, which you should bookmark, right there, that single link will always take you to the latest session of the one that's about to start. It'll give you a list of the previous sessions, and you can go back and watch the recordings of my two previous PL/SQL 101 sessions, which I held with Chris Saxon, who couldn't make it today. Also, way at the bottom, you'll find a list of resources. So there are general resources about PL/SQL. There are also specific resources about this session. So for example, I've got a blog post that we'll be referencing today that is specifically on this topic and really inspired it of which should you use, implicit versus explicit user. Cursor. I've got a live SQL script that runs through comparison of performance between implicit and explicit cursors. So the bottom line is that this one page for PL/SQL 101 office hours on fetching a single row is something you can always go back to for the recording of this session and for resources specific to this topic. And you'll see that little library of sessions and resources grow as we continue with this program. By the way, heads up also, in case I forget later, I've been doing these sessions early in the morning. It's 6 o'clock here in Chicago to give worldwide access to my expertise, but it's not so great for the United States. So what I'm going to do starting next month is shift to, I believe it's 9 a.m. Chicago time. So check your calendar, check those sessions. Do let everybody know about subscribing to the session to get reminders. And by the way, if you're joining in the session, you haven't subscribed, you haven't even signed in, that's okay. But if you do sign in and subscribe, we will give you reminders in the week before your sessions and any of the sessions, and also let you know about new office hour sessions that we're adding all the time. Okay, so hopefully you'll get a lot out of office hours and Ask Tom. And of course, if I can't answer a question today, which is quite likely because I'm good on PL/SQL, not so hot on just about everything else, you can always come back to Ask Tom and ask questions just like you always could. And by the way, if you've got questions about the architectural aspects of PL/SQL, I strongly encourage you to check out the SmartDB office hours that's run by Bryn Llewellyn, the PL/SQL product manager, and Tone Kukulars, who is one of our real-world performance experts. And they'll talk more about how to use PL/SQL to create a hard shell around your data and provide a much higher level of security and performance than you might believe was possible in an Oracle PL/SQL-based application. Okay, but we're into fetching a single row. So back over to my presentation. As you can see, lots of ways to get in touch with me. Feel free to contact me with email. Follow me on Twitter. Check out my blog, my YouTube videos. Moving along. So the interesting thing about fetching a single row is that there are so many ways to do it. And this is not an uncommon aspect of writing code. There's usually more than one implementation path. And then you might say, well, what's the best one? Well, the answer is, as usual, it depends. It depends on a number of factors. But so what we'll do is take a look at the different ways you can do things, fetching single rows, or at least some of them, the most likely candidates. Then I'll talk about some of the pluses and minuses of each one. But what I want to do is finish up on this rather quickly, get into conversation. And at any point during the session, you can click on the chat in the bottom of your Zoom box, and you can type a message to all of us or to me. You can even unmute your line if you'd like to ask a question verbally. I'm keeping all the lines muted right now. In addition, if you see a long line of boxes of faces or names on the right-hand side of your screen, if you hover your mouse over those boxes and you'll see a toolbar at the top. You can click on the single dash to hide them all, or you can just watch me if you want to by clicking on one of the single boxes. Okay, so options for fetching a single row. Number one, implicit cursor, select into, in which you implicitly, Oracle will do it for you automatically, implicitly open a cursor, fetch the row, close the cursor, select into. Explicit cursor, in which you explicitly declare a cursor and then you open it. You fetch from it as many times as you want, you close it. Then there's the wonderful cursor for loop. For every record in a select statement, get me those rows and do something with them. You could use that for a single row fetch too. And then there's the whole array of dynamic SQL alternatives. The most prominent and the one you're most likely to use, execute immediate. And it's certainly another way to fetch a single row. It's really something you only want to do when you have to do that, when you need dynamic SQL. Okay, so before I proceed, let's take a look at some code. So I put together a little script here of the different examples of the different kinds of single fetch flows. First one up, select into. So with an implicit cursor, what I'm doing here is taking some code out of the DevGem, the Oracle DevGem quiz backend. I'm passing in a comp event ID and a user. And I want to get the comp ev player ID, basically an intersection table, for those two values. So in my code, I'm going to do a select into from that table for these parameter values, that where clause. And for my single row, I'm going to return a value. And if something went wrong, I couldn't find a row, I'm going to return null. Now I'll come back and explore each of these in more detail, but let's just keep going for now. So select into, return. Explicit cursor. In this case, I'm going to take that select statement out of my executable section. I'm going to declare a cursor on that select statement. The return is the same as before. And now, instead of having Oracle open, fetch, and close, I'm going to do it myself. I open that cursor. I fetch the next row into my value. I close the cursor, return. And notice, no exception handling for no data found. I'll come back to that. Cursor for a single row. All right, why not? For record in, there's my select statement. What do I want to do? I want to get that player ID, put it in the return variable, return it. Finally, execute immediate. Again, you should only use execute immediate or any dynamic SQL option in PL SQL if you absolutely have to. So I've got my query, it's a template. I've got bind variables. I execute immediate that query using those parameter values. And I do a select into, essentially. This is the dynamic version of a select into. And then I return. And notice this query could raise no data found, just as the select into in this format. So I've got a handler for that as well. Okay, so those are the different approaches. Let's talk a little bit further about them and then get into some conversation. So first of all, before you decide which of those patterns you like, you need to ask yourself, what am I coding to? What's the state of the application? What do I expect to have happening? For example, some key questions. Will the query usually find a row, or will it mostly miss? So I'm doing a select into, pulling out that row for these input values. But do I usually expect to find a value? Or do I often expect it to miss and not find a row? Usually we're expecting to find a row, but keep in mind that question as we look at the alternatives in a moment. Are you fetching a single row, single value, a full row, or a subset of columns? How many things are you getting back? Oddly enough, that can actually help you determine which path you want to take. Is the query static, fully defined at compile time? If so, don't use execute immediate, don't use DBMS SQL, don't use cursor variables with a dynamic select statement. Just stick with implicit and explicit cursors. Hey, and is that same query used in multiple places? This will not necessarily determine whether or not you're using a select into versus an explicit cursor, but it could determine how you decide to implement that cursor. You might want to put it, for example, into a separate function if you're going to be needing it over and over again. All right, select into. In general, my feeling is that this is the go-to approach for a single row fetch. It's generally the most efficient way to fetch a single row, but the differences are not that big. Key things to remember about select into: you're not opening, fetching, closing. Oracle does it for you. But also, if it does not find a row, it raises no data found. If it finds more than one row, it raises too many rows. So select into is very specifically designed for a particular application of getting that single row. And if something else happens outside of getting a single row for your query, the select into will alert you. So that's the trade-off, or the benefit, you might say, it depends, on using select into. You're having Oracle do more work for you, but because you've handed off control to Oracle, Oracle has very specific rules about what it's going to do when it finds what it would consider an out of normal boundary condition. Now, one thing, going back to the performance issue, and about whether or not you're going to hit or miss on a query. So select into when you find a row is going to be the most efficient way of fetching a single row. But select into, if you're raising no data found, if you're mostly missing, is going to hurt your performance. Exception handling is a relatively slow process. So if you know your select into is constantly going to be raising no data found, you might say to yourself, oh, maybe it won't end up being the most efficient. Maybe an explicit cursor will. Let's take a look. So explicit cursors. They're usually a little bit less efficient than select into, but it's likely to be the case that your users will never notice the difference unless you're really hammering against that single row fetch over and over and over and over again, or many, many people doing it. Chances are you could pick an implicit cursor, select into, an explicit cursor, declare the cursor, open, fetch, close, and not really ever notice the difference in performance. And one important thing in general about performance you should keep in mind is that it doesn't matter whether or not your code is running as fast as it possibly could. What matters is that it's running fast enough to satisfy your user requirements, keep the users happy. So the other thing to know about explicit cursors is it doesn't raise no data found or too many rows. So if I'm saying open, fetch, close, let's go back to the code. If I say open and fetch and it doesn't fetch anything, well, that's for me to figure out and me to decide what to do about. And I could say fetch, I could have multiple fetches. And any one of these could be not returning a row because no data was found, but it's not going to raise the exception. You have to ask, for example, with a cursor attribute, if cursor %found or %not found, then you can take action. But it's not built into that fetch process. So here's the thing. If your query often fails to find a row, if your select into is mostly missing, switching to an explicit cursor might give you better performance because you're not going to have to handle the no data found exception. You can simply say, if it wasn't found, then do something. And the other really nice thing about the explicit cursor is that you can declare a record based on the cursor. This comes in really handy and is really obvious. Not so much when you're fetching a single value like this. So I've declared my variable based on my type. Cool. I select into it. Done. Great. Doesn't really make much of a difference if you're selecting into a single value in terms of the benefits of an explicit cursor. So explicit cursors really come in handy when you need to fetch a lot of different pieces of data. So here's a select statement with a lot of pieces of information from four different tables. And if I did a select into, I would have to declare a variable for each one of these different things. Or I'd create a record type that matches the structure of the select statement. So when you've got that kind of situation where I'm not just doing a select into X It's X, comma Y, comma Z, comma Q. Oh my God, I'm going to have 25 different declarations of variables. Yuck. Time consuming. It litters your code with all these different variables. So in that case, you take your select statement out of the select into, you put it inside a cursor, and then, so nice, I declare a record based on the cursor. So often you see table %row type, but of course you can also do cursor or view %row type. So I move it out into my cursor. I declare a variable a record based on that cursor type, and that's it. And that means that also if I add something else here, hey, I really need to get the start date too. I make the one change there. And when I recompile, my record automatically picks up the structure. And I proceed to use it. So I don't have to declare another variable, add it to the select statement, and so on. Just make a change in one place. That is one of the nicest things about explicit cursors and one of the main reasons to think about using them. Moving on. Cursor for loop. So yes, you can use a cursor for loop for a single row fetch. You don't have to worry about declaring the iterator. You don't have to worry about raising no data found in too many rows exceptions. You don't have to open and close. Oh, isn't that nice? And if we look at that code for the cursor for loop, here it is. I declare my variable because I need it. I need to get that value back. But inside my cursor for loop, I don't have to do anything else but say for record in, there's my select statement. For the one row I found, assign the value, and then return. And I suggest you don't do this. Don't do this. Don't use cursor for loops for single row fetches. For one thing, it's incredibly misleading. A loop is all about doing things multiple times, iterating through things. If you know there's only going to be one, then just stick with that. If there might be more than one, of course, you should consider using a cursor for loop, but we're talking about single row fetches. So don't write code that implies that something else is going on from what you actually know will be happening. The other thing, of course, is that it doesn't raise too many rows or no data found. So if this actually found 5 rows, it would assign the return value each of those 5 times, give you a value back, and you wouldn't realize that it wasn't the first one. You didn't realize that you've got some data integrity problem. You've got multiple rows. So you'd probably have to do something like this. Exit. Exit inside your for loop, which is a really bad idea too. It looks awful, it's unstructured, etc. So the bottom line is avoid cursor for loops when you're doing single row fetches. All right, so draw some conclusions, move to some chat and some questions. So in general with programming, you almost always have multiple implementation paths. And what you want to do is analyze your different scenarios. Am I mostly going to get just one row? In other words, am I going to get a hit on a select into that doesn't involve too many rows or no data found? How critical is performance? If it's not one of those critical path pieces, you can say to yourself, whatever, it's all good. I'll put it inside a function, whether it's select into, explicit cursor, it won't make that much of a difference. I would say that once you've determined how critical performance is, and of course you don't want to write deliberately non-optimized code, then what you want to do is keep foremost in your mind writing readable, maintainable code, so that when somebody looks at that block of code and they see a cursor for loop, they don't say, but this is just for one row. Why are you doing that? If you take a look at my blog post that's linked on that office hours page, right here, you'll find that there's a pretty lively conversation about different approaches that people take, what they prefer. Sorry, bouncing around a lot. Come back comments. There we go. We've got an enhancement request. And come back and take a look at that. We've got stories about why they choose select into, and it's really interesting in the sense that this one says, I normally use select into because I find it makes the code simpler. No need to declare the cursor, easier to understand. And then if we go down a little bit further, I never use select into because of that no data found exception handling, which adds some clutter to the code. So to some extent, it comes down to preferences. How you like to write your code, how you like to read it, how you see your code. So a question from Dennis. When talking about multi-row fetching, could you compare the ways the same way? So for multiple rows, which approach should you take? So as with single row fetching, there are multiple ways to fetch. There are multiple ways to fetch multiple rows of data. And in fact, we have lots of requirements for that as well in PL SQL. Now, I'd say the most common way to fetch multiple rows is with a cursor for loop. And a cursor for loop is a really wonderful construct in PL SQL. I think it's a great example of how Oracle took Ada, which is the base language from which PL SQL was designed, and then extended it into the database world in such an elegant way, usually. So the cursor for loop, I simply say that's the data I want, and it could be a select statement. It could also be my cursor. It could be from a cursor. And then for each row fetched, execute the code inside the body. So you don't have to open the cursor, you don't have to fetch, you don't have to close. And you essentially say, this is the data I want, this is what I want to do with it. You take care of the details for me, please. Now, the nice thing, again, another really nice thing about the path that Oracle is taking with optimizing PL SQL for database processing is that as of 10G, a long time ago, what you'll find is that this code, while it looks like it's fetching one row at a time, is actually fetching 100 rows at a time. So it's doing bulk processing behind the scenes, which is an incredibly big speed up for the performance of our applications because we're cutting down on context switches. It's similar to doing a select bulk collect. So here's another way to fetch multiple rows. And that is to say, in a single select into, it's still an implicit query. Add bulk collect. And then you're fetching all the rows identified by the where clause in the tables into my collection. And then I can iterate through the collection with a numeric for loop or other kind of loop. And this is also an optimized process. The difference in the thing to watch out here is that bulk collect will return all the rows you've identified, which can consume a lot of PGA. So you've got a cursor for loop, you've got a select bulk collect into, you've also got the possibility of doing a select bulk collect with limit. So you can say, I've got a cursor, here's my explicit cursor. I'm going to open my cursor and then fetch bulk collect limit. So this is kind of like an explicit cursor, but for multiple rows. And I can say fetch n number of rows at a time. I want to fetch 100 or 1,000 at a time. But I don't want to fetch all of them because that could blow out my PGA, my process global area. And then I exit when nothing is in the collection that I fetched. So select bulk collect into, fetch bulk collect into, cursor for loops, and also, of course, execute immediate with bulk collect. So those are a number of the different approaches you can take. In terms of the data volume, so in terms of the differences around data volume, which comes up with the select into in terms of whether or not you're finding more than one row, the big thing with multiple row fetches is that you want to avoid the row by row back and forth. So for example, if I said fetch into, so here's an explicit cursor with an explicit fetch, then this will be row by row fetching. And there's no opportunity to optimize for bulk processing. Cursor for loop does it for you automatically. Fetch bulk collect gives you control over your bulk processing and controlling the number of context switches. So in general, what you should never do, again, unless the volume is so low it doesn't matter, you should generally never do this. Have an explicit cursor open, fetch row by row, exit when cursor not found. This is a pattern that you generally would want to avoid because it's going to be the slowest way to fetch multiple rows. And from Dennis, the bulk collect feature differs a lot from the for loop approach because you're able to use the collection fetch many times. Just as a usual table, you can even use it in your SQL statements. That's right. And I think that's a really good feature. So that's a great point, Dennis. Let's go ahead and make sure everybody understands about that. So I'm going to go to my nested table example script. Nested example. Here I'm using a collection of, it's called a nested table. It says my type list of names is a table of varchar2 without any index by clause, which is what I was using here as well. I could have said index by PLS integer. This would be an associative array. And by the way, my next office hours will be on collections. So I populate my collection. Here's the point I want to get to show you, is that one of the really wonderful things about collections is that once you decide to use collections, you fill a collection from your table or even directly inside your code, as I'm doing here. you can still use them with SQL. So with a nested table in VArray prior to 12c, you could say, for every record in, select column value, that's the hard-coded name for a single scalar nested table value, from table operator of my collection. And this table operator says, take that collection, turn it into a relational data set, or looking like a relational data set, and then do normal SQL processing on it. You can join to that collection, you can do union alls, you can do minuses, whatever. Once you put it inside that from table clause, it's just like a relational table. And as of 12c, you can also use this with associative arrays. So I can now select from table of an associative array, which is indexed by integer. So they give you a really nice way of combining the strengths of PL SQL and the strengths of SQL. So I can programmatically, procedurally construct a data set right inside my code. And then I can use select from table of to work with that data. And I can take that constructed data set, put it inside a function that returns a nested table or a collection. And that table function can then be called inside a select statement. So as of 12c, you can use the table operator with nested tables, VArrays, and index by associative arrays, or index by tables. You can use all those in a table function. Let's take a look at a table function for those of you who are not familiar. So here's an example of a table of a function. Here's my function that takes some data. This is actually a cursor variable coming in. I'll show you what that looks like in the code in a moment. And returns a nested table. This nested table is a nested table of types, of object types. And the object type actually mimics the data, that the table structure that I want to put it into. So in general, with table functions, or using the table operator, you're going to be returning a single scalar value, in which case you have a hard-coded column name, column value. Or you're returning an array of object type instances. So you create the object type, the nested table on top of it, and then your function populates that array and then returns it. So here's a function that returns a collection. I can use it as a table function by putting it inside the table operator. So here's my function. I literally pass it a select statement. Here's my select statement. It's not inside single quotes. It's not dynamic. It's a select statement. My cursor expression converts it into a cursor variable. That gets passed to my function. It does whatever operations, in this case a pivot from one row to two rows. Whatever it does, it constructs the data set. And then it returns it to the SQL statement through the table operator, and then it's processed, in this case with an insert select. If I have a pipeline function, which is one of the things Dennis mentioned, with a pipeline function, so let's go back up and look at that one. Here's my pipeline function version. I'm again returning my nested table of object type instances. I say it's pipelined. And what this does is allow me to return or pipe each row back rather than filling up a local collection. So in my normal table function, non-pipelined, I declare a local collection, I fill it up, I extend to make room, I add the new object type instance, and I return it. That's a typical PL SQL function. In other words, I run all my code, and when I'm done, I return the value. In other words, my SQL statement waits for it to finish. With a pipeline version, every time I'm ready, I pipe it back out. And when I return nothing but control. I don't return any data. It's an odd-looking function if you're not used to pipeline functions. Why would you do this? Well, the reason you would do this is that as you pass or pipe rows back to the calling query, and pipeline table functions can only be called inside a select statement, non-pipeline table functions can be called in normal PL SQL. Anyway, as the rows are passed back, the select statement can take advantage of it. So in the little script that I wrote here, we go back to the, what I've done is add where row number is less than 10. So only get me the first 9 rows. I don't care about all the rest of it. And what you'll find is that the performance of the pipeline function is way better than the non-pipeline version, because this query is grabbing each row as it's piped back. And as soon as it gets 9, it says, I'm done, stop the function. And it terminates the function. With the non-pipeline version, you might construct an array with 10,000 rows in it. You pass back the 10,000 rows, consuming all the processing time, all the PGA. You pass it back to the query and it says, oh, I just wanted the first 9 rows. So that's one example in which pipelining can be enormously performant. You also commonly use it with parallelization, parallel-enabled functions in data warehouse operations. So Dennis, I'm not sure that answered your question, probably some of it, but I thought it'd be a nice little segue into just explaining the difference between pipeline functions and non-pipeline table functions. And again, in 12c, you can now use them, use the arrays. So if I can now use a collection. So here's my associative array. This is an example of how you can now bind collections, but I can also select from table of the collection. So this was never possible before 12c. And now we're basically giving you the same functionality across all the different types of collections, with the exception in some cases still of string indexed arrays. Can you please share the table function SQL code or give me the web link? Well, so here's a tip for you in general. Use Live SQL. So Live SQL, which is where I've put the script for the comparison of implicit and explicit cursors, is a a website where you have live access to an Oracle database instance. In fact, 18c, if you're not yet up, you don't yet have access to an 18c database, you can come to livesql.oracle.com and check out 18c features. Now, what I've done is put a lot of different scripts. We'll just take a look at my little library of scripts. I put about 200 PL SQL scripts in here. So these are all my public scripts. I've got over 200 now. And my suggestion is you come here and do some searching. So let's go to the home page. And let's look for table function. And as you can see, lots of examples of using table functions. So pretty much my suggestion is that you come to Live SQL. If you've got a question about my code, come to Live SQL and take a look at and just do a search on the keywords. And then you can dive in and take a look at the different examples. And you'll see examples. For example, this is a streaming table function example. So we go through building up a function, populating the collection, showing you how to use it in the table clause. I've got explanations here. So my answer would be, in general, go to Live SQL, check out my scripts, and you'll almost certainly find what you need. And if you can't find it, let me know. Follow me on Twitter, put in a request for an example, and we'll get to it. Okay, thanks for joining me for this latest PL SQL 101 office hours. Hopefully you've enjoyed learning about different ways to fetch single rows and exploring the alternatives.